In this exercise, I will configure the autoclave unit model that we configured in the project that we used in section 2. So we'll go and open that project. So to open it, we go File, Open Project, and navigate to the folder where you saved it, in our case, SysCAD Tutorial, Test 1, and we double click on project.spj, and that will open our project up. So in this case, we're going to configure the autoclave. So if I right click on the autoclave, we get the access window. The first thing I want to do is I want to set the pressure in the autoclave. And that's up here, requirements, operating P, which is the pressure. At the moment, it's running at atmospheric pressure. If you click on the little down arrow, you can see we can change that. And we'll use required P. So we want to set the pressure that we're going to run the autoclave at. Click on required P. And now you see we can set the pressure. At the moment, it's atmospheric, 101.33 kPa. We want to set that to 1,500 kPa. So I'll type that in, and you'll see it's still blue, and it'll remain blue until I click the OK button. And there it is. The result field, shown here, this grey field, will only change once we have solved SysCAD. And please do note again that your white field is where you can make a change as a user, and the grey field is calculated by SysCAD. So we've now told the autoclave that it will be running at 1,500 kPa. And the next thing we wanted to do is we wanted to work out the equilibrium with the water and the steam. So what we'll do is here in the evaluation block, VL equilibrium, at the moment it's off, and that stands for Vapour Liquid Equilibrium. We'll go and turn that on. So on auto sequence, and you'll see it now has a VLE there. And we've got a new tab now called VLE, standing for Vapour Liquid Equilibrium. If I click on that, you'll see it's using water, H2O. And when we solve it, what SysCAD will do is it will try to run this unit at the equilibrium point at 1,500 kPa. So it'll try to get it to the equilibrium temperature for that pressure. So if I now solve this project, and to do that, if I push this run, SysCAD will go and solve that. And now if I have a look at this tank, you'll see there the result, the pressure is now 1,500 kPa. And if I right click on one of the streams coming out of this autoclave, if I right click on P007, you'll see it's at 102 degrees Celsius. And if I click on the SP page and go hide 0 so I can see all the flows, there's no steam coming out of that autoclave. So what SysCAD has done is it's condensed all the steam to try and get it up to the equilibrium temperature at that pressure. And if I look at the Q0 page here, you'll see 1000 kPa, the saturated temperature at this pressure is 198.3 degrees Celsius. So SysCAD is trying to get this unit to that temperature. There's insufficient steam to get it there, so it's just condensed all the steam that it does have. But if I have a look at the pipe, what's flowing out, 4,500 kilograms an hour is flowing out of that pipe, and the same amount is flowing out of here. So this, in a tank or a tie, unless you as the user set the split, SysCAD will divide the flow out of that equally. But in our case, we want all the gases to go out of P006, out of our vent stream. So to get SysCAD to do that, if I right click on the autoclave, here near the bottom of the first page of the tank, there's a thing options, split flows. And that's how we tell it how it must actually split the flows out of the tank. So if I click on that, we then have another tag here called GM, which stands for General Model. And if I click on there, you'll see the two streams coming out as P006, which is the vent stream, and P007, which is our slurry stream. We're going to set P006 to take all the vapors, so we want that to be the top stream, the top here, because with SysCAD, we can only set one of these two streams. The other one has to be free. So we want P006 to be at the top. If yours is not at the top, just go and change the priority from auto to 1. Click on the OK button, and you'll see it'll then move to the top of the two streams. There's a few ways you can change how you split the streams in a GM model. As you can see here, mass fraction, we can set the mass flows, the volume fractions, volume flows. But here we can set the phase mass fraction, which is what we need for this autoclave. So if I click on phase mass fraction, by default it's set my P006 to have 0% solids, 0% liquids, and 100% of the gases. So that means that all the gases will go out of P006 and the solids and liquids will go out of P007, which is what we want. We could change it. We could have a small amount of entrainment. We could say we want some liquids to go out with the gases as well. But in our case, we'll leave that as 0. So having set that up, if I now push solve, you'll see now that P06 has changed color. It's gone this light blue color. And if I right click on it, you'll see there's no flow going out of there because there are no gases coming out of the autoclave. So we've now set up our autoclave to run it at required pressure, 1500 kPa, to do our vapor liquid equilibrium, and to split the gases to come out of the vent.